Hey guys, we are on unit 2 now. Unit 2 is about graphing on the Cartesian plane, and we're going to start with the distance formula and the midpoint formula today for 2.1. So we graph on what is called the Cartesian coordinate system, or you can just say the coordinate system, or you could just say the plane, a flat surface, but it's spelled P-L-A-N-E. It's a flat surface that extends forever infinitely, like the infinity symbol, infinitely in all four directions, right? And so this would be a plane. Ooh, hold on. Sorry. So these are planes, or we can just write a new one real quick. It's a flat surface. It goes on forever. You can zoom out, zoom out, zoom out. It's like the universe, it goes on forever. And we divide up the Cartesian plane with two number lines. So this would be the x-axis. It is a number line going horizontally, like the sun. And then we have the y-axis going vertically up and down. And we draw arrows at the end to show that these number lines also go on forever. The number lines will divide the Cartesian plane into four coordinates. You can just say Q1, they often use Roman numerals for the quadrants. Q1, Q2, Q3, and Q4. All right. Points. That would be a point on the graph, right? Each point has a coordinate. Since this is the origin, this is where the x-axis and the y-axis meet, the origin. The coordinates of the origin are 0, 0, because all measurement starts at the origin. And if you don't move, you went 0 and 0. So this is called an ordered pair, right? So we have the ordered pair 0, 0. Down here we have the ordered pair 3, 2, 3, -2, -3, 1. All right, so it's parenthesis, the first number, a comma, and then the second number. The first number is always your x. The second number is always your y value. Okay, so just like you have an x-axis and a y-axis, the x number tells you where this point is according to this number line. The y, the second number, will tell you where it is on the graph according, or on the plane, according to the y-axis. Okay? So basically the first number tells you how many to go left or right. The second number tells us how many units to go up or down. Okay? So like 3, 2, for example, that's 3 is the x, 2 is the y. So we would go starting at the origin always, starting at that origin 0, 0. We'll take our x value first. So we'll go over 3. 1, 2, 3. Okay. And then we'll go up 2. 1, 2. And then we'll draw our point. And the ordered pair for this point is 3, 2. Okay. So -2, -3. Negative, right, on the x-axis, negative will be this way to the left, just like on a number line. Positive will be to the right. On the y-axis, positive will be up, negative will be down. Okay, so we went to the right here because it was a +3. We went up because it's a positive 2. Here, because we have a -2, -3, we're going to go back 2 and down 3. And that's -2, -3. Okay. So this is just, there's a lot of graphing in Unit 2. That was just a quick review of graphing. If you have any questions about graphing, reach out so that you feel confident about the rest of this unit. Okay. Where points are on the quadrant. Let's do that really quickly. So this point, -3, 1, this would be in quadrant 2. Yeah. Let's write that down. The point -3, 1 is located in quadrant 2. The point 0, 4, or the ordered pair 0, 4, is located, let's look at this. So we go 0 on the x, we do not move on the x, and then we go +4 on the y. 0, 4, we don't say, it is not actually in a quadrant, we say is on the y-axis. So last one, the point, how about -2, 0 is located, where do you think? On the, so we go -2 and we don't go up or down, x-axis. Technically not in a quadrant, yeah? The point 0, 0 is located at the origin. Is the origin. So that's just a little introduction to the plane before we get started with our distance formula, okay? The things you should know. Point is ordered pair, and it's just a way to find your directions on the plane. Okay. X, where to go right or left. Y, where to go up or down. Okay, and it's always in that order. First is your first number will be X, your second number will be Y in your ordered pair. Okay. Page 2, slide 2, I should say. Okay, the distance formula, let's just talk about what these letters are, all right? D stands for distance. P with a small 1, that's a 1 below it, we say call it a subscript, sorry. Subscript 1, so P sub 1 means point, and the 1 means it's the first point, so we can say point 1. Then you're going to have a P sub 2, right? That stands for point number 2. Within each point, there is an X and a Y, right? So let's look back at this. -3, 1. Okay, I'm going to take that. I'm going to call that a point. Point -3, 1 has an x, -3, y, 1. Okay, I just broke down the point into its x and its y. So P1 is 0.1, P2 is 0.2. So x1 and y1 are part of P1. P1 is made up of a 1x and 1y. P2 is made up of 1x and 1y, but because it got a sub 2, we're going to give this x a sub 2 and this y a sub 2. Okay, so 0.1 is made up of x1, y1. 0.2 is made up of x2, y2. Okay, because every point has a location with an x value and a y value. All right, so the distance formula is saying that the distance formula for these 2 points, right? The distance between. All this is saying is the distance between 0.1 and 0.2. Or you could even say the first point. 0.1 and 0.2 equals, right? The square root of the quantity of the second point's x value minus the first point's x value squared plus the second point's y value minus the first point's y value quantity squared. Right? Because we know how to read this. It's a square root, that's a square, we're subtracting, we're adding, right? The newest part here is the subscript. So just remember the subscript is to tell apart 2 similar points. Okay. And the reason we skipped that part. The reason we need a distance formula. Why would we need a distance formula? Let's look at a graph. So I've got this graph. Here is x, here is y. Let's say this point is 2, 1. Okay. And then down here, we've got 2, -3. And then here we've got -4, 1. Okay, got 3 points. What if I want to know how far away each point is from the other point? Between -4 and 2, but it's flat, right? They're all on the 1 y value. The unit for y is 1. So I could just count, right? 1, 2, 3, 4, 5, 6. The distance is 6, right? Or I could subtract. -4 minus 2 is a distance of 6, right? The absolute value of -6, which is 6. Same over here. 2, 1 and 2, -3 have the same x value, so we know they're in a straight vertical line, straight horizontal line, straight vertical line. So I can just count between -3 minus 1 is the absolute value of -4, which is 4, or 1, 2, 3, 4. Counted up 4. Okay, but what about this one? This one we cannot just count if it's not straight. So the distance formula is if you're in a situation where you don't have vertical line or a horizontal line, your line is at an angle and you need to find the distance. All right, so let's use the formula. The formula will work for a straight line. Use the formula to find the distance between the points. Let's just call this point 1. So I'm going to say this is x1, y1. Okay. Call this point 2. So this is x2, y2. P1, P2. The distance formula says the distance O2 comma 4, 5 equals the curviest square root ever. X2 is 4 minus x1. X1 is 0, square it, plus y2, that's 5, minus y1, that's 2, squared. Good. 4 minus 0 is 4 squared. 5 minus 2 is 3 squared. 4 squared is 16, right? 3 squared is 9. Oops, sorry, always going off the page. 16 plus 9 is 25. What's the square root of 25? It's 5. So the distance between these 2 points is 5, and we could say units. All right, let's do another one. -4 is my x1. 5 is my y1. 1 is my x2. 3 is my y2. I have a negative here, so I want to make sure to use more parentheses than I did over here, just to be careful. So the distance between -4, 5, and 1, 3 equals x2, 1 minus -4 squared plus y2, 3 minus 5 squared. All right. So now I've got 1 minus a -4. 1 minus a -4 becomes 1 plus 4, right? 1 plus 4 squared plus, what's 3 minus 5? -2 squared, which becomes 5 squared plus -2 squared, which becomes 25 plus 4, right? Because when you square a negative, you get a positive. So that becomes the square root of 29. You can't make the square root of 29 into anything. There aren't any factors, right? It would just be 29 and 1. And they always want it in simplest radical form. All right. So leave this in simplest radical form unless the test or the homework tells you to do something different. Simplest radical form. 25, the two factors are 5 and 5, right? And so we could take 5 out. It was a perfect square. 29, we can't take anything out. So the simplest radical form is just square root of 29. That is the distance, the square root of 29 units, you could say. All right, next we have a triangle, and we have the use of the Pythagorean theorem. The Pythagorean theorem says a squared plus b squared equals c squared. okay, when these are each parts or sides of a triangle. So we would say leg 1 squared plus leg 2 squared equals hypotenuse, the longest side of the triangle, squared. So that's what the Pythagorean theorem says. All right, so this says consider 3 points, -3, 1. We have to draw a graph. -3, 4. I think they're all, it looks like there aren't any negative y's. So I'm just going to make my graph like this. So I have more. 1, 2. All right. Plot each point and form the triangle ABC. So point A is -3 on the x, 1 on the y, and we'll call it A. We don't need to put the points because it has a name. B is -3, that same -3, up 4. 1, 2, 3, 4. And then C is 4, 1. So those are my 3 plotted points. Now I need to turn them into a triangle. Because A and B both have -3 as their x, I know that this is a vertical line. Because A and C both have 1 and 1 as their y, I know this is a horizontal line. So this is a horizontal line intersecting a vertical line. So I know that's a 90-degree angle, right? And then the last one, BC. Those do not have any coordinates in common, any x's or y's in common. All right, plot each point and form the triangle. Find the length of each side of the triangle. So which ones can I count? Can I count any of these, or do I have to use the distance formula 3 times? I can count this, right? So between 3 and -3, we went 4 and 1. So I can just say this is 4 minus 1, right? Let me make sure you see. So that's that 4 value and that 1 value. I subtract them, yeah? And that's how I find my distance. 4 minus 1 is 3, or I can just say 1, 2, 3 and count it. So this is 3. Do it again with the C and the A, right? That looks straight. And they both have a 1. So C and A are between -3 and 4. -3 minus 4 is -7. And when you change that to a distance, it just becomes 7. So this distance is 7. So we have 3, we have 7, and we don't know this one. B and C, the points. So we want the distance BC is x minus x squared plus y minus y squared. Oops, 1. That should be a 1. So my B was -3, 4. And my C was 4, 1. X1, Y1, X2, Y2. X2 is 4. X1 is -3. Y2 is 1. Y1 is 4. Four minus a -3 becomes a 7, right? Because it's 4 plus 3. So we have 7 squared plus -3 squared. So that becomes 49 plus 9, right? 49 plus 9 is 58. And same thing here, simplest radical form. 58 can go into, I think, only 2 and 29. So we can't pull out the 2, we can't pull out the 29 because neither of those are squares, neither of those repeat, right? So the distance between B and C is the square root of 59 units. And then is this a right triangle? Is this a right triangle? If it's a right triangle, the distance, let's look at this. If it's a right triangle, AB squared, that distance, plus the other shorter distance, AC squared, will equal BC, the longest side, squared. All right, so we'll just quickly replace those. The distance AB is 3. So we have 3 squared. AC is 7 squared. And we found that BC is the square root of 58 squared. So that becomes 9 plus 49 equals 58 because the square and the square root cancel each other out. 49 plus 9 is 58. So yes, this is a right triangle because it is proven by the Pythagorean theorem, and because I know that this is perfectly vertical and this is perfectly horizontal, this is a 90-degree angle. Any triangle with a 90-degree angle will be a right triangle. All right. Next one is the midpoint formula. The midpoint formula has this similar subscripts, right? 0.1, x1, y1, 0.2, x2, y2. All right. So you have 2 points and you want to find the middle of the 2 points. All right, so a line segment just means part of a line. So I'm going to make up a point. This point is, let's say on y, it's 0. So we're just right on the number line. So we're going to say this is -2, 0. And then we'll say this one is 4, 0. Okay, so we're right on the x-axis. Between these 2 points, what would be the midpoint? The midpoint will divide it exactly into 2 equal halves, right? So between 4 and -2, what would divide 4 and -2 in half? The distance is 6, right? The distance is 6. So if I go up 3, I could find the midpoint. Right? There are 6 between 4 and -2. So if I move 3, I will be halfway. That will give me 1, 0 is the midpoint. But again, if it's at an angle, it's harder to find, okay? So what we're going to use is the same points and X and Y values, but we're going to put it into this formula. So for example 3, add the 2x values, divide by 2, add the 2y values, divide by 2, and it'll give you a new point. Okay? You're just finding the average of 2 x values, then you're finding the average of the 2 y values. And again, you can make either one your 0.1 and your 0.2. P1, P2. So that means this is x1, y1, x2, y2. What is the middle of these 2 points? The middle is going to be an x, y, right? Just like right here, x, y. And that x, y will be x1, -4, plus x2, 3, divided by 2, comma, y1, 5, plus y2, 2, divided by 2. Okay? But let's do this one at a time. So the midpoint of x is -4 plus 3 over 2. Right? -4 plus 3 gives me -1 over 2. So x is -1/2, right? The midpoint of y is 5 plus 2 over 2, which is 7 over 2. So this becomes -1 over 2, 7 over 2 are the coordinates of the midpoint of this line. Okay. Let's just look at this real quick. So we had the x, right? And for the x, we used the values -4 and 3, right? We put them here, and we ended up with this x. For our y's, we use the 2 y values, 5 and 2. We put them here. And we got the average of the 2 y points. So now let's do -4, 3. The midpoint of -4, 3 and 2, 2. So the midpoint of x is, x1, y1, x2, y2. Okay, so x is x1, -4, plus x2, 2 over 2. -4 plus 2 over 2 is -2 over 2, which becomes -1. Y will be y2. I don't know why I start with y2, sorry, that's confusing. Y2 plus y1, or you can switch them because it's addition, over 2, which is 5 over 2. So the midpoint of -4, 3 and 2, 2 is -1, 5/2, right? And this should actually be, this should be a 3. And this should be the 2, because getting them out of order is not a good habit to get into. All right, so we did all our x's, we got -1. We did all our y's, we got 5 halves. We used the y's, we got 5 halves. We used the averaged the x's and got -1. All right, last piece. We're going to try to use the same formulas, but extra analysis. So not a new skill, but just an extra analysis. You're thinking about it differently, okay? The midpoint of a line segment from P1 to P2 is 5, -4. If P2 is 7, -2, what is P1? 7, 5, all right. Oh, and they're all negative, okay. It's too dangerous. I'm gonna do it over. I'm gonna do it over here. All right. The midpoint, we make a graph. Okay, here's my X and my Y. The midpoint of a line segment is 5, -4. I'm going to go over 5, down 4. That's my M. P2 is 7, -2. P2 is 7, -2. What is P1? P1, but we don't know what it is. Okay. The midpoint from P1 to P2 is 5, -4. P2 is 7, -2. What is P1? So I need P1. I have P2. I have the midpoint. Okay, should I use the distance formula or should I use the midpoint formula? The distance formula, I would need X and Y. The midpoint formula, I can use M1, sorry, I can use X and Y of M and X and Y of P2 to find the X and Y of P1, okay? So the X of the midpoint is the X of 1 plus the X of 2 over 2, right? And we should label these. So this would be X2, Y2, XM, you could say, YM, because it's not point, this one's 0.2, this is the midpoint. So that's why I labeled it M. So now I can just substitute those in. XM is 5, equals x1 is what we don't know. So I can just leave it. Plus x2 is 7 over 2. Okay. And don't worry that you have this 1, like you have to do something special. It's still just the variable x. Okay. Just the variable x. So I have 5 on this side and I have a fraction on this side. I want to get rid of my fraction. So I'm just solving for x now. Multiply it by 2. Anything I do to this side, do it to this side. Multiply by 2. Two times 5 is 10. We multiplied in order to cancel those. So now we have 10 equals x1 plus 7. So now I just need to subtract 7. So I get 3 is x1. So the x of 0.1 is 3. Now I'm just going to do the same thing for y. Instead of xm, it's going to be ym equals y1 plus y2 over 2. Ym equals y1 plus y2 over 2. The y of my midpoint is -4. -4 equals, we don't know y1. We know that y2 is -2 over 2. So I can also rewrite that as -4 equals y1 minus 2 over 2. Again, I want to get rid of the fraction, so I'm going to multiply by 2. Multiply by 2. y1 minus 2 is -8. Add 2. -6 is y1. So I got 3 for my x. I got -6 for my y. So P1 is 3, -6. Let's see if that fits. 3, -6. 1, 2, 3. 1, 2, 3, 4, 5, 6. Good. It's not perfect because those lines are not evenly spaced, but we did find the value of P1. And those are our notes for today. Thank you guys very much and see you next time.